Today, we will be talking about the synthesis of alcohols and how we would produce carbonyl compounds, several carbonyl compounds, to produce these alcohols. Now, before I get started on talking about the main reagents used to make these alcohols, I'm going to let you see which carbonyl compounds we will be using. So first, we have your aldehydes. Your R group attached to the C double bond H. That's one group we'll be talking about. Second group, your ketones. This just has one R group, and then it has another R group, the R prime, which will be any different type of substrate attached to your C double bond O. Third group we'll be talking about are your carboxylic acids. Your R attached to your C double bond O attached to an OH group. And finally, the fourth group we'll be talking about are the oh so wonderful esters. Yep, you have an R group attached to your C double bond O attached to another O attached to an R prime, which is different from your original R group. Now, when dealing with these carbonyl compounds, the way we reduce them is we'll be using a couple different reagents. These reagents don't really vary, it's just dependent upon how quick of a reaction you want to do and which carbonyl compounds will actually synthesize into an alcohol with this reagent. One reagent we'll be talking about is NABH4. This is most commonly used for the aldehyde and ketone groups because it's safer and easier to use than your second reagent group, which is going to be your LiAlH4. But then you're wondering, if you have NABH4 for your ketones and aldehydes, then why would you need to use LiAlH4? Well, when it comes down to esters and carboxylic acids, it's a little bit more trickier. Esters can be synthesized to alcohols from NABH4, but the thing is, it'll be really slow and the reaction will take a long time. And NABH4, when dealing with carboxylic acids, won't even synthesize. So that's when LiAlH4 comes in for esters and your carboxylic acids and synthesizes to your alcohol reaction fast and quickly. So I've set up a few flashcards to help see and figure out which reagents we might use or which product will be formed. So here we have an ester. Now we see that the final product is RCH2OH with your R prime OH. So now what would be your reagent that we would use to get this final compound? Well, remember, esters could be used with NABH4. The thing is, it'll go really slow. So the best idea would have to be to use LiAlH4 and with your second compound being H3O to finalize and get your OH. So that's your esters. Next, we have your carboxylic acid. We see that you start with carboxylic acid and you have your reagent, so what your final outcome be? Now remember, you're synthesizing to an alcohol. When you synthesize using LiAlH4 for this carboxylic acid, you'll end up with a primary alcohol. So in the end, you'll receive your RCH2OH. Another compound is your ketone. And here I've listed that you can use either LiAlH4 or your NABH4. And don't forget, when you use LiAlH4, it's mixed with ether, and NABH4 is mixed with ethanol. So your final product on this would be a secondary alcohol, being R prime C to an R to your H group to an OH. Last but not least, we have our aldehydes. Now this is missing the reagents that could be used that produce the primary alcohol. What reagents could be used? Well, remember, ketones and aldehydes could use either NABH4 or LiAlH4. So either could be correct. NABH4 though would probably be your most probable one to use because it would be faster, easier, and safer. So you have either or that you can use with NABH4, LiAlH4, and then your H3O is final. So now you know how to synthesize alcohols using reduction for carbonyl groups. Hope you learned something, and thank you. Bye.